All right, so the instructions for number one, pretty straightforward. It just says to simplify. And it's really kind of a couple of problems in one. It's 125 over 25, x cubed over x, and then y over y to the fifth. Do any of these stand out to you where you're like, oh, I for sure can do that?
The middle one with the x.
Okay. So you're always subtracting. So your answer is x to the 3 minus 1, like that, which is x squared.
Mm-hmm.
Let's do the same thing for the y. It's 1 minus 5, which is to the negative 4 power. Okay, now 25 does not go into 120 perfectly, but they're both divisible by what number?
5.
By 5, yeah. So 5 there, and then this top one is 24. Okay, so our answer right now is 24 x squared y to the minus 4 over 5. Whenever you have a negative exponent like this, it goes down to the bottom.
Yeah.
So it's going to end up looking like this: 24 x squared over 5y to the power of 4. Is that okay?
Yeah.
Great. Okay, so let's take a look at number 5 next. Sorry, number 4. I don't know why I said 5. Well, it's got 5s in it. Okay, so the very first type of factoring that you're supposed to always do first is greatest common factor. And that's why I grabbed this problem here, because they all have a greatest common factor. So when you look at 5n plus 15, is there a number that goes into both?
5.
5. So this becomes 5 times n plus 3. How about in the bottom one here?
4.
4 times n plus 2. And then top one is 2. And then the bottom one is 3. And you make some cancellations. So you did this in problems 2 and 3. So if the factor is the same on the top and the bottom, you can cancel.
Yeah.
So that n plus 3 cancels with that n plus 3, the n plus 2 cancels with the n plus 2. And then what's left over, you multiply on top and multiply on the bottom. So 5 times 2 is 10. 4 times 3 is 12. And if you can, you reduce this fraction, which means you could have reduced it in the previous step. For example, you could have said, oh, 2 and 4, those cancel, but you can also do the same thing here. Just divide each by 2, and you still get 5/6.
Right.
All right, let's look at number 6 now. The work you have on the other problems looks good. For example, number 5, though, you've kind of didn't finish the problem, but it's all correct up to that point.
Okay.
Copy, paste, paste. Okay, now it worked. All right, so the new problem here. So this one on the lower left, this one has a greatest common factor. What is that greatest common factor?
10.
10, yeah. And what goes inside parentheses?
X plus 2.
Perfect. Now you should be on the lookout for ones that might cancel with it. Okay, so the question here is what about this up here? How do you factor x squared plus 4x plus 3?
Oh my God, I forgot what it's called, but I know how to do it.
Okay, so go ahead and do it and tell me what goes down in the bottom here.
X plus 3, X plus 1.
Yes. Are there any cancellations now?
Yes.
Yes, there's lots of them. There's X plus 3 and X plus 3, X plus 2 and X plus 2. What is left over on the top?
1.
1. Yeah, very important there. And if you need to, write it, because you don't want to just leave nothing. But on the bottom, it's 10 and X plus 1 is what is left over. Any questions on that?
No.
Okay. All right, I'm going to go down to number 9. Number 9 here. Okay. We definitely worked some problems like this last time we worked together, solving. And the first thing I mentioned is to make some exclusions, like figure out where the denominators equal 0. You might get a exception here. This one just says to show your work for the instructions, but sometimes they say to check your answer. And that's when you know you're going to be on the lookout for something. So you're setting X plus 7 not equal to 0 because X cannot equal -7. So basically you're saying, okay, if I get an answer of -7, I know that that is not correct. So hopefully you don't get -7.
Yeah.
That's really the point here. Like, because on a test you might. All right, now in terms of like how to solve this, you have to make a common denominator. And what's nice is they're all sort of the same. They've all got an X plus 7, but this middle one has a 2. Okay, so that means that your common denominator is going to have a 2, which means you're going to have to multiply the first terms by 2, and then the ones to the right of the equal sign by 2, excuse me. The next one will be a little more sophisticated than this, but it's essentially the same process here. Once you figure out the common denominator, you look for what's missing on the top and the bottom and multiply. Very important to not miss this minus sign. So it's 2 times 3x minus 8 equals minus 22 times 2. So you can forget the bottom. You don't have to rewrite it as far as I'm concerned. Okay. So that's 6x minus 8 equals minus 44. And from here, you just solve the way you've done for many years here. 6x equals minus 56. Divide by 6. And that does not work because I didn't add correctly. Wow. Minus 36. So x equals minus 6. These are designed to work out nicely. So if you get an answer like I was about to get, that's how I know there's probably a mistake. Any questions on that?
No. So as long as it's not -7.
You're good. Yes.
Okay.
So that, yeah, I mean, it actually wouldn't have been that hard to make this one into one that does not work. You just needed this number up here would have only had to been slightly different to get it, but yeah, it's possible.
Okay.
But again, usually they say to check your work or check your answer when there is an extraneous solution. Your teacher's got some interesting worksheets that you've been given over the past few months. I don't know what to tell you.
Okay.
Maybe just ask, you know. All right. New problem here, problem 10. It says to solve each equation, show your work. We in this problem, when there's something to factor, you should factor first before you set the bottoms equal to 0. And most of the time it ends up factoring into the thing that's already there. This one ends up being x minus 6, x plus 2. And that's good because that makes it less complicated in terms of what to multiply the other ones by. So you want to figure out your exclusions, your excluded values. And you do that by setting the bottom not equal to 0, x plus 2 not equal to 0. So x cannot be 6, x cannot be negative 2. And as you just said, as long as the answer is anything but those, you're good.
Okay.
All right, so now you have to decide what is missing from the bottoms for the common denominator. This is the hardest part, I think. It's like, what is missing? Well, the common denominator is the one on the right. This down here is your common denominator. So you ask yourself, what am I missing when you look at 2 over x minus 6? Well, you're missing x plus 2 and an x plus 2. And then the 7 over x plus 2, it's missing an x minus 6 and an x minus 6. So from here, do you agree that the denominators, the bottoms, are all the same?
Yeah.
And that's really critical, because if they're all the same, that means you can just look at the numerator. You don't have to rewrite the denominator. 2 times x plus 2 plus 7 times x minus 6 equals 4x plus 2. Will you try solving this for x for us?
Mhm.
Let me know what you come up with.
I got x equals 8.
Yes, that is perfect. It's not one of the excluded values. You don't really want to check these. They are very hard to check. So just if you're concerned on the quiz test tomorrow, just go ahead and check through your work again rather than trying to put it back in here. Because it's bad. It'd be like 2 over 2, that's okay. 7 over 10, not okay. And then 32 plus 2 is 34 over 64 minus 32 minus 12. I mean, that just it gets bad. Yeah. All right. So can we move on to the graphing, or do you want to spend any more time on this first page?
We can move on to the graphing.
Okay. All right, here we go. So we've got a function. Your teacher gives some instructions. Good idea to only do the things that they ask for. It saves you time, reduces your chances of doing something wrong. Before you do any of this, though, you really want to factor. You want to factor the top and you want to factor the bottom. And the very first type of factoring you're always supposed to look out for is greatest common factor. Is there a greatest common factor in the numerator and denominator? The answer is yes. Could you try factoring that for me, please?
So I got x parentheses x minus 2 over 3 parentheses x minus 3.
Perfect. That's exactly what you want to get. And now we can actually now we can actually do some of these things. So the first one you want to always try for is the vertical asymptote. And this may be like a note card or something you refresh yourself on before the test, but it's where the bottom equals 0, the denominator.
Right.
So that's setting x minus 3 equal to 0, and you get x equals 3. So it's a little bit different than when we were solving the rational equations. You gotta graph a vertical line here.
Are we gonna have is there gonna be 2 vertical lines or is there gonna be 3?
There's only one because you're only setting the bottom equal to 0, and you're only specifically setting the terms with x equal to 0. See how this 3 does not have an x with it?
Yeah.
So you're just setting the stuff in parentheses equal to 0.
Okay. And then how many like dotted lines are we gonna have?
One horizontal and one slant, it looks like. I'm sorry, one vertical and one slant.
Okay.
So in this problem, we've got to, so the order doesn't matter. I guess I like doing verticals first. In terms of easiness though, the x and y intercepts are probably the next easiest. And then the slant asymptote is the hardest. Let's do the x and the y intercepts next. So the y-intercept is when x equals 0. You put 0 in for x. And you can do it in either form. Sometimes it's better to work like with one or the other. I think it's better to work with the non-factored form for that. So it's like saying 0 squared minus 2 times 0 over 3 times 0 minus 9.
So it would be 0 over -9.
Yeah, which ends up being 0. So that's an ordered pair. That's 0, 0. All right, so now we're going to do the x-intercepts. So the x-intercepts are when you set the numerator equal to 0. So that's where you want to use the factored form. X parentheses x minus 2. You want to set that equal to 0. So you set each factor equal to 0. So x equal to 0, and then x minus 2 equal to 0. So the second one here is when x equals 2. And for both of these, y is 0. That's the whole point. For the x-intercept, y is already 0. For this first one, x is 0, y is 0. So those are two more ordered pairs, 0, 0, and 2, 0. And we just so happen to already have this one. Okay, but now we'll go back up here and put another dot, 2, 0 for that one. Now we need the slant asymptote. And did you get confirmation you are going to use polynomial division for this?
Yes.
Okay. All right, so to do this, yeah, you got to go down here and you got to figure out what goes inside the house, what goes outside the house. So 3x minus 9 goes here, x squared minus 2x, and you really should put that constant, even though it does not exist there as well.
Okay.
This one's a little bit tougher. You started it, it's not great. Like normally you're like, oh, it's x, because x times 3x gives you 3x squared, but that's too big, right? You want it to go smaller, so that's why you need 1/3 out in front to get just the x squared. And it's very important that you put it in the x column. Like on your work, it looks like you started putting it in the x squared column. It really should line up with the x's.
Okay.
Then you've got to multiply both of these. So it's 1/3 x times 3x, that gives you x squared. 1/3 x times -9 gives you minus 3x, like that. And you're subtracting, you've done long division in the past. I like to change the signs here rather than subtract, because then I'm adding. So negative, positive, and then I add vertically, so that becomes 1x. Bring the 0 down. Okay, and it's again kind of an awkwardness because it is a fraction, but it's like, what do you multiply 3x by to get x?
1/3.
1/3. Now, if that's really uncomfortable for you, you could say, what do you multiply 1x by to get 3x, and take the reciprocal of that? But you've got to be okay to come up with some of these fractions. And you don't have to go any further than this. Hopefully your instructor confirmed that, so you don't end up spending a lot of extra time here, because this is your slant asymptote. It's an equation of a line. Okay, and as review, it's got a b value of 1/3 and a slope of 1/3. So you might want to put a few dots on there. I guess I'll do it in a different color here. It's like that, and then the slope is rise 1, right 3, rise 1, right 3, and so on. Like that, like that. So it's something like that. And then the question is, well, do you feel like you have enough here to be able to graph this without a calculator?
Um,
And it's reasonable to say no, like I have no idea, but so the help is that you're supposed to put these arrows along the asymptotes as you graph them. And so the idea here is that you need to connect the dots, but you're not allowed to cross the slant asymptote or the vertical asymptote. So maybe you just pick like, oh, I can see that has to be the case there.
mhm.
And then, well, it can't cross, so it must be that one. So then these must kind of connect together like that. And then generally they are kind of top right, bottom left, or top left, bottom right. They're sort of on the other sides, something like that.
Okay.
What about this do you feel like you could not do after we've done a problem like this?
I just don't think I'm the best at long division in this context.
Okay. Do you feel like you can figure out the vertical asymptotes, the y-intercepts, and the x-intercepts?
Yeah.
Okay. Let's focus on the long division then for the next couple of problems. All right, so let's actually do the slant asymptote first for this one. Sorry, my screen is okay, there it is. Okay, so we're gonna do the division here again. Minus 3x plus 6 into x squared minus 2x minus 8. Let me know. I guess you've got this down already. So it's again, it's really awkward. So it's like what we need to get to x squared. So just focus on the x. What do you multiply x, get x squared? Well, it's x, right?
Yeah.
It's x. So how do you make a number smaller? Well, it's a fraction. This one just happens to be 1/3 again. That gets you down to 1x, but it's negative, and we really want it to be exactly this leading term. So that's why the negative goes here. Like you have to get x squared in that first position.
Okay. So it would be, so the x squared comes from the 1/3 x.
The minus 1/3 x.
Okay.
Because the negative times negative makes positive. The 1/3 times the 3 makes 1, which we didn't write, and x times x makes the x squared.
Okay. And then you do,
You got to multiply both terms.
so
So
you
you need
multiply 1/3 by 6, negative 1/3 by 6.
negative 1/3 x by 6, yeah.
Yeah.
And that becomes negative 2x.
So it would be 0 after you switch the signs, and then you bring
Yeah,
back
and that's a
8.
little bit different. So then you bring the minus 8 down. And the problem is that nothing goes into this. Like you can't get from minus 3x to minus 8. So you're effectively done. Like normally there should be something where the 0 is, then you'd have another term, but this is your equation now.
Okay.
You don't like that, do you?
No, it's kind of weird.
Yeah, it's different. So actually, let's back up here. So when you put the 0 there, you're trying to figure out how many times does minus 3x go into 0. So let me give you just an analogous problem here. Let's say you're doing 7 into 140. And you're like, oh, 7 goes in 2 times. 7 times 2 times 7 is 14. You subtract and you get a 0 here. How many times does 7 go into 0? 0. And that's kind of the analogy here with this problem. Like minus 3x goes into 0 0 times. So you put plus 0 up here in the top.
Okay.
All right,
And
so
then
go ahead.
for the remainder, do you do like,
You don't need the remainder.
okay,
You stop right here. You don't keep going.
okay,
That's what I was trying to say. Hopefully your instructor didn't like make you keep going because you don't need anything past that point.
okay. It's just sometimes she made us do like, I think it was like negative, for example, it'd be like -8 over -3x plus 6.
That's true. That is the correct way to do it, but that's if you're dividing. If you're just trying to find the slant asymptote, you just look at the quotient.
Oh, okay.
All right, so to graph that, it goes through 0 and that has a slope of negative 1/3. So down 1, right 3, down 1, right 3, and so on. So that's your slant asymptote for this problem. I'll do I'll help out with the other stuff. So this thing factors into -3 x plus x minus 2. So there's a vertical asymptote at 2. And then the numerator factors in x minus 4, x plus 2. So it's got a x-intercept there and there. And then the y-intercept ends up being down here. So I know I got a lot of dots. But in terms of like how you connect this, so if you draw some arrows, you can only cross, you cannot cross the vertical or the slant.
Right.
So that's the only possibility.
Okay.
Okay, and then similarly over here, it's the same idea, like it can only cross there, and they're generally opposite on signs. So we've got a couple more problems we can look at. They don't necessarily get any better, but they're more practice. Just
Okay.
the way it goes. I'm sure there's swimming stuff that you just don't enjoy, or isn't, almost a burden. I don't know. I don't know. Maybe enjoy it all. All right, so let's do the division first. You've started this already. Can you give this a try here for the first term up here? What do you multiply 4x by to get x squared?
Would be. I'm just gonna take a guess.
Okay, so
But
don't guess. Let me show you the shortcut. I don't like this, but this is what you're doing. You're actually doing x squared divided by 4x. That tells you what to put up here.
So would it be 1/4 x?
Yes.
Okay.
So let's go back to the previous problems, and I'll show you that for all the previous problems here as well. So you can see that. So I'll do it in this blue. So it's really x squared over minus 3x that gets you back to this one. And then in the previous problem here, it was x squared over 3x gets you to the 1/3 x. It's always these two.
Okay.
All right, so now why don't you keep going here, see if you can give me the next number here.
Would be +2.
Yeah, let's give this a try. So it's x squared plus 2x. You subtract or change the signs, that ends up being 3x.
Mhm.
Okay, so to figure out what goes up here, it's 3x over 4x.
So it'd be 3/4.
Yes.
Okay.
You've got to remember the order though. That's why I don't like doing this approach, because it's kind of like a recipe that works for this problem, but doesn't work for all the others.
Yeah.
But it will work for this test.
Okay.
So that may be good enough here for you. How's your grade in the class, if you don't mind me asking?
It's not the worst, but it's not the best.
Okay, so is a lot riding on this test?
Not a lot.
Okay,
But
so you got a chance here. If you do well, you could really shoot your grade up, which is what we want to have happen here. Now, to graph this line, which is a little awkward, you start with the b value, which is at that 3/4, kind of right there, somewhere below 1. And then what is your slope? What is the slope of your slant asymptote?
1/4.
1/4. So you just got to get in the reasonable space, like up 1 over 4, up 1 over 4. Just kind of reasonable. Like that.
Okay.
Now, if we factor, could you factor the numerator for me, please?
It would be x plus 4, x plus 1.
Very good. Now, vertical asymptotes are where the bottom equals 0. You just set the x term equal to 0. So the vertical asymptote in this problem is when x plus 2 equals 0 or x equals minus 2. And this is when I actually would draw those little arrows that I've been doing in the previous problems.
Okay.
So now we need the x-intercept and the y-intercept. Let's do the y-intercept. That's when x equals 0. And you end up just getting down to that 4 over 8 because it's 0 squared plus 5 times 0 plus 4, 4 times 0 plus 8. So it ends up being 4 over 8 or 1/2. So that's the y-intercept. So it's right there. Well, it's not, that's great. It's right about there, a little bit above that. And then the x-intercept, you set the numerator equal to 0. And that's because y equals 0. So you're setting that x plus 1 or x plus 4 times x plus 1 equal to 0. You set each of those equal to 0. So you get x equals minus 1 and x equals minus 4. So those are your two crossings.
Right.
And this is, I mean, I agree, this is hard to do because you've got to connect some things here, but you cannot cross the slant or the vertical. So like here's what you can't do. You can't be like, oh, that right there, like that doesn't work because you can't cross the slant. I know it's probably hard to see, but so sometimes it's good to connect like two things that you know have to connect. And you're like, oh, that must go down there, and then that one must connect over there, off to the right. Okay, and then top right, bottom left. Something like that.
Okay, I think I'm getting it.
Well, great, because we've got at least one more problem we can. Although this one's a lot more difficult than the last, but it's still doable. This one does not have a slant asymptote.
Oh.
No, I'm sorry, it does. I apologize, it does. You're not going to get something like 7 on your test, is my guess.
No.
So we should do something different here. So, okay, let me give you another one to try. Is there anything else you want us to cover for your test?
No.
Okay, so let me make one up here. Let's say f of x equals x squared plus 5x plus 6 over 2x plus 2. Okay, so I guess I'm going to ask you to find the slant asymptote.
I got 1/2 x plus 2.
All right, let me take a look here. That sounds pretty good. Did you do that? Did you take x squared and divide it by 2x to figure out what goes in the
Yeah.
top? Yeah. Okay, very good. Yeah. So it's 1/2 x, and that gives you x squared plus x, change the signs, 4x plus 6. So you get plus 2. I think that's what you said. Yeah, perfect. All right, very good. All right, how about let me ask you to find some other things for this one. Let's go, yeah, let me grab this again. Could you tell me the vertical asymptote for this one?
I got x equals -1.
Okay, very good. And how about the, let's go with the y-intercept.
0, 3.
0, 3, like that. Okay, and then the x-intercept, there's 2 of them.
-6 and +1.
Yes. -6, 0, and -1. No. You did not factor this correctly. Sorry. Let's try factoring that one more time. 2 numbers that multiply to 6 but add up to 5.
I said +6 and -1.
Okay, but they
Is that not right? Am I not thinking?
let's foil that. You get x squared. That's how you check. Minus x plus 6x minus 6 plus 5x minus 6. So it's got to be exactly the same.
All I'm thinking.
Yeah, and I wasn't trying to be deceptive with this one. I just was trying to choose one that we hadn't done before. They're both positive. Both factors are positive. I almost let you talk me into these other answers.
Oh, it's x plus 3x plus 2.
Yes. And you would have seen an issue on your graph. You would have been like, that doesn't look right. And you would have struggled to graph it. So that maybe is a learning lesson there. Okay, to do that. So you got -3, 0, -2, 0 for that. So to summarize today's a couple of things we did, I'll just go back to the first few problems we looked at. Power rule. Don't forget your exponent rules. If it's a negative exponent, it goes to the bottom. All right. Try to break it apart into pieces that you can do. For the next couple of problems, we did a greatest common factor. So be on the lookout for that. And then you cancel whatever's left over. The next type of factoring we did is called a equals 1, but for you just got to be able to correctly get the factors and cancel as needed. For the solving problems, make sure you determine what it cannot be. I don't think there'll be any exceptions.
Okay.
And then figuring out the common denominator. So just that's where your effort should be. What's the common denominator? This second one we did, you had to factor and decide, okay, is it the same? Yeah, it's the same. You figure out what's excluded. and what's missing. And you just work it out from there. And then we did a bunch of these, 3 or 4 of these graphing problems. You seem to have it all down. Slant asymptotes are where you divide. Vertical asymptotes, you set the bottom equal to 0, x and y-intercepts, setting x to 0 or the numerator to 0. So just somehow remember those rules. And I mean, you probably could get your best grade ever on this test, really. I mean, if you understood what we were doing today, it seemed like you were following along, and I think it could go well, could go real well.
I hope so.
All right, we'll try to share some of my optimism as you go in there. It's always good to have a positive attitude and, you know, visualize doing well on the test.
Okay.
All right, well, that is it for us for tonight, Paige. Thanks so much for letting me help you, and hope you have a great rest of your night, and I'll see you next time.
See you next time.
Okay, bye now.
Bye.